we're going to work on the most important function in pre-calculus. It's called quadratic functions. Okay. Quadratic function looks like this. F of x equals ax squared plus bx plus c. Here, a, b, c, they are all real numbers. Okay, so for example, we have this quadratic function f of x equals 2x squared plus 12x plus 13. This is a very typical quadratic function. So every time when you see the quadratic function, then it looks, you can write like this. All right, now I want you to complete a square. Okay, let's see how should we do that. And do you remember when we learned how to complete a square, I want you to check whether the coefficient of the square term is 1. But this is not 1. Okay, so what I'm going to do is I'm going to take a 2 out. X squared plus 6x. If I do this, then I can complete a square here. Okay, do you remember how to do that? Once the coefficient of the square term is 1, and then we take half of this, the first degree coefficient, half of it, then square it, we plus and minus that number. So half of 6 is 3, and the 3 squared equals 9, right? So we're going to plus 9 minus 9, which is 2 times x squared plus 6x plus 9 minus 9 immediately, okay? And then plus 13. Let's simplify because we know this is a complete square. So that's 2 times x plus 3 square, and then 2 times negative 9, because this 9 goes to here. All right, and then this is negative 18 plus 13. All right, so then I combine like terms, I got this, because negative 18 plus 13 is 3. This one is another format of a quadratic function. So this is one way to write it, and this is another way to write it, and this is called the vertex form. All right. Now this is the standard form. So if you want to change that from standard form to vertex form, you got to complete a square. You got to do that. All right. Now the vertex form generally writing looks like this: f of x equals a, okay, x minus h squared plus k. You might say, hey, hk again. Yes, we use this a lot. And the vertex in this form is hk. All right. Now you compare this with the vertex form we're given here. Where is the vertex? What is my h? Remember, here's x minus h, here's x plus 3. So h in this case is negative 3. Okay, opposite sign. However, the k is not. See, here is a plus k and here's a negative 5. Therefore, my k is negative 5. So the vertex is negative 3, negative 5. Okay, so that is the good thing about that. All right, then the quadratic function in this form, and there's one more number here. It's a. That's a real number a. It's the same thing as this a. They should be exactly the same. Do you remember we factor that out, right, when we complete a square? So I want to tell you something about this a. When this a is a positive, a is not 0, okay? If a is 0, it's not a quadratic. It's going to be a linear or something else. So a is not 0. However, when a is greater than 0, when a is a positive, greater than 0, when x becomes a huge number square it is also a huge number, and then you multiply by that, so it goes up. And when x goes to negative infinity, when x is like a negative 1,000,000, and then you square that, you get a very, very big positive number. So a is a positive, that's a positive number. So it's going to look like this, because that's the end performance, right? So we call this is open up. So when a is a positive, your graph open up, and when a is less than 0 or negative, it goes like this, it's open down. Okay, now see, we have this, if we have this vertex form, we not only know the vertex, that's the coordinates of the vertex, we also know the shape, whether it should be open up or open down. And what else we would know? Remember, the vertex is here is -3, -5, okay? And also this graph, it's a symmetric along this line. What is this vertical line? That is x equals -3, isn't it? So in another word, my axis of x equals h. See, you know this. And once you know all those informations, I think it will help you a lot to graph. All right. And then one more thing. Okay, so every time when we talk about the graph, there's a couple of things. And what is the x-intercept? Could be more than one. What about the y-intercept? Okay, quick review. What does that mean? Y-intercept is the y value when x equals 0, right? And the x-intercept is the x value or values, because we don't know how many we would have, when y equals 0. Okay, which one is easy? I think this one is easy. When x equals 0, what is y? When x equals 0, 0 minus h, which is -h, square it is h squared. So ah squared plus k. So the y-intercept is ah squared plus k. Again, you don't have to remember this. You just need to know how to get that. And for the x-intercept, we'll do this a little later. Okay, so we learned open up, open down, the vertex. We know the axis of symmetry, and we learned what is the y-intercept. I think probably we should learn to graph one, okay? So we graph this. I ask you to graph f of x equals 2 times x plus 3 squared minus 5, which is exactly the one quadratic formula of quadratic function we got earlier, and in the vertex form. So let's see, what do you know? The vertex is -3, -5. Remember, a times x minus h squared plus k. That's a general form. Okay, so what is the vertex? It's hk, right? Okay, I write it that way. So we know the vertex, and we know a equals 2 in our case. So a equals 2, which is greater than 0, so open up. See? Okay, positive, so open up. So the shape looks like this. Okay, what else do we know? We know here x equals h is the axis of symmetry. Axis of symmetry. That will be x equals -3. Okay, what else? Y-intercept, right? Okay. What is the y-intercept? That's when x equals 0. What is y? So f of 0, which will be 2 times 0 plus 3 squared minus 5. 3 squared, 9. 2 times 9, 18. 18 minus 5, 13. Okay, so this is the y-intercept. Now, if you happen to have this form, the standard form, f of x equals ax squared plus bx plus c, when x equals 0, the first two terms are 0. So C is your y-intercept. Okay, we actually know that, right? And because the formula we have here is the 13. See, that's your C. All right, so we have that. Can we graph? Here's x, here's y, here's a 0, and I need a -3, -5. So 1, 2, 3. That's -3, and of course here's a 1, and here's a 1, here's a -1, 2, 3, 4, 5. So that is my vertex. And I know I need to have like a open up because I have an a positive too. And where's my y-intercept? It's a 13. My goodness, it's way up because here's 1, 2, 3, 4, 5. It's all the way up. Okay, it's out of my graph. But anyway, so I should be able to graph something looks like this, isn't it? Ah, too close. It should be very, very high. I'm so sorry. It should be a little flat. No, forget about that. So that's your graph. Okay, that's your graph of this function. Now the most important one is where is your x-intercept. That's where it's going to cross your x-axis. When you cross the x-axis, that's where your y equals 0. Okay, so do you know how to solve it? Do you know how to solve y equals 0? And what is x? Okay. Let me, if you have the vertex form, say your y equals 2 times x plus 3 squared minus 5. Can you solve it? Yeah, solve for x. We plus when y equals 0, right? So here is 0. So 2 times x plus 3 squared minus 5 equals 0. All right? And then we plus 5 on both sides, then divided by 2. So 2 times x plus 3 squared equals 5. And then I divided by 2. So x plus 3 squared equals 5 over 2. If you like, you can write a 2.5, but it doesn't matter. I just write like that. Okay. And then how do you do the next step? You have to take square root. So x plus 3 equals plus or minus, because you might have a 2, 5 over 2. Either positive or negative will be the solution here. And then we subtract 3. So x will be -3 plus minus square root of 5 over 2. Of course, 5 over 2, you can use 2.5. If you want to use calculator, you can go 2.5 and the square root of it, it's going to be like a 1 point something. And then -3 plus that and -3 minus that, you get a 2x intercept. That will be where your graph will cross the x-axis. All right, now, what about if you're not having the vertex form? You have this, f of x equals ax squared plus bx plus c. If you have this form, then how do you find out the solution of this equals 0? Or how do you find the x-intercept? Okay, a magic formula. I keep saying magic, but it's not magic. It's just, it's called quadratic formula, okay? So 2a here, and then -b plus minus root b squared minus 4ac. All right. So once I give you this quadratic formula or quadratic function, you should be able to identify what is a, what is b, what is c, then plug them in here. Okay. And then when you plug them in here, a, b, c, everything, then remember here you got to take the square root of this guy. If b squared minus 4ac is a positive, you take the square root of a positive, then you have two, there are 2 x-intercepts. Why? Because you take the square root of a positive number, and here you're going to use a plus or minus, okay? So if a b squared minus 4ac equals 0, then this part is 0, so your plus minus 0 doesn't make any difference. So there's only one x-intercept, which means your graph will touch the x-axis and go away. Okay. When you have b squared minus 4ac is negative, when this part is negative, you take the square root of that, you don't get a real number. So, which means no x-intercept. No x-intercept means your graph will not touch the x-axis. So you might have something looks like this. Okay. Or you might have something look like this. So they always have the y-intercept, but sometimes you might have a no x-intercept. Can you see that? All right, now we're going to do an example of this guy. This b squared minus 4ac has a special name. Okay, what is that called? Discriminant. Discriminant. That's the name of it. Okay. All right, now we're going to solve this one. 3x squared minus 2x plus 4 equals 0. Can you solve it? First of all, I would ask you to identify a, b, c, and then plug that into the formula. So in this case, a is the coefficient of the square term. Okay. B is the coefficient of the first degree term. Okay. And your c is the constant term. You get A, B, C? Okay. Let me give you the formula again. I guess if you work enough times, then you should be able to remember this. Okay, I know a lot of people can remember this. All right, now we plug that in. The denominator is 2a, which is 2 times 3. Later I'm going to write 6. Here, negative b, my b is negative 2, so it's going to be negative 2 plus minus, I just simply substitute. The b is negative 2 squared minus 4 times 3 times 4. Okay? So far, so good. And then the denominator is 6. I'm going to move this up. Denominator is 6, and here negative 2, which is 2, plus minus the square root of. Okay. Negative 2 squared is 4. Okay, right here. Put a little note. Minus 4 times 3, that's 12. 12 times 4 is 48. So 4 minus 48 is negative 44. That's a negative number. So what are you going to say? You're going to say there is no real solution. No real solution. Okay. And when you graph that, this graph will not touch or cross your x-axis. Okay. So do you see that? All right. Now, I really hope that you can remember this formula. If not, you might want to write it somewhere so you can always have that handy. So in this part, we learned the quadratic formula. This is the most important function. Quadratic function is the most important one in the pre-calculus. And we learned the two forms of it. One is the standard form, the other one is the vertex form, and you know how to find the vertex by completing square. And then you find the axis of symmetry, and you know how to determine whether the graph should be open up or open down. And also you learned how to find the x-intercept, or to solve for this quadratic equation, which is the same formula here. Okay, 2a, then the numerator is negative b plus minus the square root of a discriminant. Discriminant is b squared minus 4ac. If you like, you can try to get this formula by yourself, but I guess you're not very interested. If you do, please leave a message and let me know. All right, good luck.